Okay, so we are recapping what we learned yesterday. 9.1 is just vocab, so you got to relearn all the vocab, or not relearn, but make sure that you know all the vocab. 9.1.
Can you know that for the test? Like, section for matching vocab, or just like?
I think we just need to know how to do it, like know them so that we know exactly what we're doing.
Yes.
Okay.
Yeah.
Right. Okay, then in 9.2, one thing that we learned is if you have two segments that are tangent to the same circle, they're equal to each other. So this was the ice cream cone thing, right? Because it kind of looks like an ice cream cone, or the dunce kid, however you want to remember it. I don't really care, as long as you know that those two segments are going to be equal to each other. Okay? So if you have two segments tangent to the same circle, those pieces are the same. Okay? Then in that same section, we also learned that if you draw a radius to a point of tangency, what happens?
Oh, it's perpendicular.
Yes, it's perpendicular to the tangent line. So a radius drawn to the point of tangency is perpendicular to the tangent line. So that looks like this. If I have some circle, I have some tangent line. If I drew in a radius to the point of tangency, I know that the radius would be perpendicular to that tangent line. Okay, those are the main points of 9.2. There was also the tangent lines between two circles. So, I mean, we can just jot that down. It's all in your notes already, though. But if you have two circles and one line is tangent to both and it passes in between them, we call that internal tangent. So that, my circles are not great. So that's a common internal tangent. I would love it.
Last year's English class was 10 people.
And then there's a common external tangent.
Please don't bring up that.
At this time, students from the field trip, the Harriet field trip, will be headed to the DUI class. Again, please admit these students without a field trip, Harriet field trip, so that we can have their DUI class.
Oh, when they get here.
What's it?
Yeah, so
Oh. Back when you used to be like really mean to kids, like if a kid got a question wrong, you could send them to the back of the room and they had to wear a big hat that said dunce. It means like dummy, yeah.
We should do that.
No. If I want to get fired real fast. Okay.
ice at them.
No. Of course not. All right. So those were your main takeaways from 9.1, 9.2. 9.3, that starts all the arc stuff. Okay? So that was make sure that you know how to name arcs. Name arcs. So we had major, minor, semicircles.
I had a question on the like degree of, because
Yeah.
I saw like problems that had like degrees on the outside, but then it was like find a degree like on the inside.
Right.
It was-
So that's another tidbit that you need to know. So that's a big deal. The measure, hi guys, of
I don't know who sits here, but I saw her.
an arc is equal to the measure of its central angle.
Oh, I did not write that down.
Yeah, so let's do a little picture of that over on the side here. So if I have a circle and I have this central angle here, if I told you that central angle was 70 degrees, the measure of arc AB would be 70 degrees. So let's jot that down. So if the measure of angle ACB is 70, then so is the measure of arc AB is also 70 degrees. So they're interchangeable.
Oh, okay, that makes a lot more sense because I did not have that written.
Yeah. Central angles and the arcs, same exact measure. So we like that. And that was really your main takeaway from 9.3. Yeah, that's pretty much it. And then 9.4 had a lot of weird stuff in it. So, for those of you just coming in, I'm just sort of recapping what we learned in 9.1 to 9.4. So far, this is all on video, so hopefully it'll keep recording and you can just get whatever you missed. Okay, 9.4 is a little bit weird. Let's see. You've got, if I have a circle, and in that circle, I have two chords that are congruent to each other. So let's say I have that. If those two chords are the same, so let's put some letters. And I'm also going to draw in, well, maybe not yet. If I know that, if I know AB, segment AB is congruent to segment DC, that means that arc AB and arc DC also have to be the same. It would also mean that their central angles have to be the same. So I don't have any central angles drawn here, but you can always draw them in if you want to. So if I just kind of eyeballed the center of my circle, and then I drew in those, so here's central angle 1, and then if I drew this in here, there's central angle 2. Angles 1 and 2 would have to be the same as each other. And what was so cool about this is that all three of those pieces are tied together. The chord, the arc, and the central angle. So if any of those pieces are the same as each other, so are all the other pieces. So if I gave you another circle where I told you this central angle was the same as maybe this central angle. E, F, G, H. Let's do that. So if I started you off with this, now you know, because the central angles are the same, that means that arc EF and arc GH have to be the same, which makes sense, right? Because if the arc is the same, if they're the same measure, if that's 10 degrees, that's 10 degrees, so then that's 10 degrees and that's 10 degrees. So all those pieces would be the same. And the other cool thing that you get here is if you were to draw in the chord. So if I drew in chord EF and chord GH, they would have to be congruent to each other. Okay? So that's kind of the first bit of 9.4, is that any of those pieces, if you know any one of the three, you know the other two. You get them kind of for free. All right? So there's the first big part of 9.4. The next big part of 9.4 is that, and this is really the most important part of 9.4, in my opinion, if you have a diameter that's perpendicular to a chord. So let's just look at a circle. I have a diameter, and, oh, that's not a diameter. That's my chord. Let's draw a diameter that's better than that. Like that. So if I know that I have a diameter perpendicular to a chord, we learned yesterday that what has that diameter done to that chord? It bisects it. So I would know that these pieces are now the same. Is that okay so far? And then the only other piece of 9.4, sorry, I'm a little distracted. I don't know what's going on out there. Sure. Okay. So this last bit says, if I have two chords equidistant from the center, what do I know about them? So here's the center of my circle. Here's some random chord. Here's some other random chord. If I know that they are equidistant from the center, so remember how to measure a distance from a point to a segment, it has to be a perpendicular. So I would drop a perpendicular to both of those. And if I know that they are congruent to each other, so there's my two chords that are equidistant from the center, right? Right? What do I know about those chords now, Dylan? Yes. I said Dylan, but it's okay. Yes, they are congruent. So in other words, segment AB and segment CD must be congruent. So that's what we had talked about yesterday. So there's your takeaways for 9.1 to 9.4. So honestly, if you knew just these things, you're a good portion of the way there. So I will upload these to this page. I mean, it's all in your notes, but it's sort of just notes highlighted. I get to use my fancy scanner thing and put it up on the Google Classroom. So oh sure, I guess you could. Well, it's not gonna. You can't see it very well. I mean, yeah. All right, so let me stop this